Hi folks, it's Dion Bozak from Sky Analytics. Modern aircraft operators manage flight safety in increasingly complex airspace environments. Restricted zones, special use airspace, temporary flight restrictions, and company-defined corridors all coexist, often with both lateral and vertical constraints. In mature FDM and FOQA programs, the challenge is no longer simply detecting exceedances. It's understanding where operational interactions occur and whether spatial patterns emerge over time. Within Sky Analyst FDM, geofencing extends traditional parameter-based monitoring into the spatial domain. It allows safety teams to define airspace volumes and apply event logic directly within the same environment used for analysis, trending, and operational review. Recent industry experience has reinforced how critical both lateral and vertical containment can be, even in routine operations. Geofencing provides an objective way to identify and review these interactions post-flight within a structured safety framework. Airspace is defined as a three-dimensional volume with precise lateral boundaries, vertical limits, and geographic positioning. Airspace models are defined using KML files. You can use a tool like Google Earth to create them or use a text editor for extra precision. Once the KML file is created, it's a simple process to import it into Sky Analyst FDM. Once the airspace is defined, spatial event logic can be configured to align with an operator's procedures and risk model. Events may trigger on entry into a volume, for example, when monitoring restricted or sensitive airspace, or on exit, such as when tracking deviations from standard arrival, departure, or containment corridors. As the aircraft enters the defined volume, Sky Analyst FDM automatically detects the transition using recorded flight data. The airspace changes from green to red, clearly indicating that the aircraft is now inside the monitored boundary. When the aircraft exits the monitored volume, the event concludes and the airspace returns to green. This provides immediate clarity, not only that an interaction occurred, but how long the aircraft remained within the defined boundary. Once this information is captured, spatial events become part of the broader FDM analysis environment. They can be reviewed and trended just like any other event, allowing safety teams to examine the frequency of airspace interactions over time, clustering by location, altitude, or phase of flight, or changes following procedural updates, training, or just operational growth. Spatial event definitions of this kind are not commonly available in traditional exceedance-only FDM implementations. They provide an additional layer of operational context supporting deeper insight into how aircraft interact with airspace constraints in day-to-day operations. As airspace complexity continues to increase, mature safety programs require more than threshold detection alone. Geofencing in Sky Analyst FDM helps transform flight data into spatially grounded operational insight, supporting proactive safety management, procedural clarity, and continuous improvement at scale. Now, if you'd like more information on how our geofencing functionality can help improve safety within your operations, please send us an email at info@scaleanalytics.com. Until next time, fly safe.